In this lesson, we will learn how to simplify powers raised to a power. We'll also learn how to simplify the product of powers raised to a power and the quotient of powers raised to a power. So when exponential expressions are raised to a power, the expressions can be multiplied to simplify the exponents. So we're going to show how we verify this rule by expanding our expression. Now notice, we have a power raised to a power. So my first expansion is we're going to expand the 2. So we have 2k to the thirds. Now we're going to expand the 3 on each k. So I have k times k times k times another set of k to the thirds. Now, when we write this as a single factor, we really have k to the 1, 2, 3, 4, 5, 6. K to the 6 is my final answer. Now we have 8 squared raised to the power of 3. We're going to first expand the power of 3. So we have 8 squares. 1, 2, and 3. Now let's expand our powers of 8. We have 8 times 8 times another 8 times 8 times a third 8 times 8, giving us 8 to the 1, 2, 3, 4, 5, 6. So 8 to the 6th power. Example 3, we have x to the negative 2 raised to the power of 4. So we're going to first expand our power of 4, and we have 4x to the negative 2s. Now, when we expand each x to the negative 2, we're going to reciprocate it. So x to the negative 2 is really 1 over x times x. And I have another 1 over x times x, and a third 1 over x times x, and my final one, 1 over x times x. This gives me 1 times 1 times 1 times 1, 1 over x to the 1, 2, 3, 4, 5, 6, 7, 8. 8 x's being multiplied. X to the negative 2 raised to the 4th is 1 over x to the 8th. So this time we have a power raised to a negative power. So the way we're going to simplify the negative is we're going to put 3 squared in the denominator, and I have 4 of those. So I have 1 over 3 squared times 1 over 3 squared times 1 over 3 squared, and a fourth 1 over 3 squared. And then when we simplify the 3 squares, we have 3 times 3, 3 times 3, 3 times 3, and a fourth 3 times 3. So on the top, we have 1 times 1 times 1 times 1. And then on the bottom, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 1 over 3 to the power of 8. So I'm not sure if you noticed a pattern here, but if we take a look at when we have a power raised to a power, if we simply multiply 3 times 2, we get 6. 2 times 3, we get 6. Negative 2 times 4 will give me x to the negative 8, but remember, we simplify by reciprocating this factor. Then the last one, if we apply the quick rule, 2 times negative 4 is negative 8. And again, once we reciprocate, we do get our answer. Let's do 4 problems here, and we're only going to apply the rule. Remember, leave no negative exponents. Here, I have 3 times 4, so I have c to the 12th. I have b to the negative 5th. Again, we're going to reciprocate. We have 1 over b to the positive 5. Here we have a base of 2. We're going to multiply power to a power, and we get a positive 8. In our last example, we have m as our base, and we're multiplying negative 3 times 8. That gives me negative 24. Once we simplify this, we get 1 over m to the positive 24. Okay, moving right along. This time, we are still going to use the same rule, but we have more than one factor here. But it's the same idea. So we're going to expand the 2, the outside exponent. So I have 2 j squares k to the thirds being multiplied. So I have 2 of these factors. Now we're going to expand. And then once we put it all together, we have j to the 1, 2, 3/4 power times k to the 1, 2, 3, 4, 5, 6 power. Number 10, we have 3 8 squares x to the negative 1 and a third 8 squared to the x to the negative 1. Okay, now we're going to expand each of these. So we have 8 times 8 over x, 8 times 8 over x, and 8 times 8 over x. So altogether, we have 8 to the 1, 2, 3, 4, 5, 6 power over x to the third. And our last example for here, we have 3 4x to the negative 2, 4x to the negative 2, and 4x to the negative 2. And the reason we're learning how to expand this is if you ever forget any of these power rules, you can always expand and show what's going on and then simplify it back together. Now we're going to expand. We have 4, and then we have x times 4, x times x, and a third 4 over x times x. Remember, I'm putting my x's here in the denominator because I have a negative power. This 4 has a positive 1 power here, so it's understood 1. This negative 2 is only applied to this factor of x. Now, let's simplify this. So I have 4 to the third, and then I have x to the 1, 2, 3, 4, 5 power of 6. Let's apply the product to a power, which just simply means this exponent is multiplied by every exponent within the parentheses. So each factor has an exponent, even if it's just an understood 1. So here, what I suggest is I'll always write in my 1 so I don't forget that this b does have an exponent. And you're just going to multiply this exponent of 4 times the exponent of all my factors inside the parentheses. So I have b to the 4th and c to the 12th. Again, I'm going to put in a 1 here, and I'm going to multiply my outside exponent times every exponent within my parentheses. So I have 3 squared, and then I have f to the negative 2. Now, when we're working with these small powers, we can go ahead and evaluate if we want to. So that is going to give me 9. And then I need to take care of my negative exponent, and I bring my f to the 2 to the bottom, making it positive. Again, we're just going to multiply every factor's exponent by the outside. V to the negative 4 times w to the positive 8, which gives me w to the 8 over v to the 4th. And our last one, we have 2 to the positive 6, and then m to the negative 12. We can simplify this. So 2 to the 6 is, let's write this out. 1, 2, 3. So that gives me 4, another 4, and another 4. That gives me 16, and that gives me 64. So 64 over m to the positive 12. And the last section of this lesson is the same idea, but this time it is going to be the quotient raised to a power. And it's the same idea. This exponent is going to be multiplied by every exponent of each factor inside, but let's expand. So I have 2 a to the thirds into the 2's. Now let's expand each of those. So I'm going to have a times a times a over n times n times a times a times a over n squared. So on the top, we have a to the 6th, and in our denominator, we have n to the 4th. 17, we have 3, 2 over k to the negative 2. We have 3 of these. And the only simplification or expanding here is we're going to bring the k up to the top and write 2 of them. So I have 2 from here, and then I have k times k, another 2, k times k, and a third 2 times k times k. So we have 2 times 2 times 2. That is going to be 2 to the third, and k to the 1, 2, 3, 4, 5, 6. And then if we want to evaluate 2 to the third, that gives us 8k to the 6th. And the last one. Okay, this time we are going to expand. We have a negative 2. And so this is just going to switch this p to the negative 1 and this q to the 2. We're going to flip-flop it around because this is going to be applied to both. So we are going to have q squared and p, excuse me, to the negative 1. So the reason I'm reciprocating these is because the outside is, excuse me, is negative. So again, we're going to have a second one of those. And now we are going to expand this. So we're going to have q times q. And then we're going to bring this p back to the top because it's negative. So the first time, we did not worry about the negative, the original exponent, okay? We just simply evaluated this negative by reciprocating our rational expression. And then we have q times q for this part, and then we bring in the p to the top. So altogether, we have q, 1, 2, 3, 4 raised to the 4th power, and p raised to the 2nd power. Now, let's practice a few of those just by applying the rule. Again, you're going to multiply this outside exponent times every exponent inside of that parentheses. So, and again, if there's no exponent, there really is one. It's an understood one. You may want to write it in. So here, I am going to simply multiply 3 times 4 and get 12. And then in our denominator, we're going to have 4 times negative 2, which is negative 8. Simplify this, k to the 12 times h to the 8. Number example 20. Again, I want to write a 1 in on this base, 2 to the 1st, so I don't forget. So I have d to the 8th, 2 to the 2nd, w to the 6th, and if we want to go ahead and evaluate 2 squared, we can do that. Again, I'm going to put my 1 for 3 to the 1st here. I'm going to have 3 to the negative 3, a to the negative 12, and 0 to the negative 3 is simply 0. Now, let's clear up all and simplify further. 3 to the negative 3. We know we're going to have to reciprocate this, and we're going to bring it to the denominator, and that gives us 27. A to the negative 12 is going to be reciprocated, and it comes to the denominator, making a positive exponent. And b to the 0 is simply 1. So 27 times a to the 12th times 1 is simply 27a to the 12th. And so we need a 1 in our numerator. Cannot leave it blank. In our last example, x to the positive 6 over 2 to the positive 3 and y to the negative 3. We're going to simplify 2 to the 3rd, which is 8, and we're going to have y to the negative 3. It's going to reciprocate and come to our numerator, making it a positive exponent. Now, you practice these rules 1 through 12.